Hey everybody, welcome back to the Unreal Engine live stream. I'm your host Alexander Pascal, and joining me today is Ian Shadden.
Hey guys, how's it going? I'm not dead yet.
Yes.
Yet.
Unfortunately, he was a little bit under the weather and couldn't make it to the last training stream, but we got him now. He's only slightly under the weather and much better now. So that's
I'm hopped up on cough suppressant. So we'll see how this goes.
Welcome to the live stream where we're drinking cough suppressant.
All day, all time.
Cool.
Yeah.
So on to the line traces and ray traces and shape traces.
Yeah, we're gonna trace a whole bunch of things up today.
And I said we should actually probably also clarify, not ray traces.
They're not ray traces.
But a lot of people use that term, so we wanted to make sure that it was out there so you all knew.
I mean, we use line segment traces. I mean, if we're being accurate, I guess. But whatever. I mean, standard industry terminology, ray trace. So, well, I guess not really. I mean, if we were to examine ray traces from the standpoint of a renderer, I mean, then we get into, never mind. Moving on. So
Getting a little too in-depth.
I have started up a new project here. We're in the first-person template.
And we're in 4.14.1 for those of you who are going to ask which engine version. It is the latest.
Yep. So really, there's just standard stuff here. And really, it's just so that we have something to walk around so we can look at the things that we're going to make that are going to do our traces for us. So really what we're going to start off by doing is just kind of get in and build a new actor so that we can, so we can start stress testing, so we can start getting information back from traces and so forth. So let's create a new actor, and we'll call it our trace actor. We're going to go really original right here.
All right.
And I'm going to create another one right now.
Just straight out another actor again.
Just to do sort of like I'm going to do a radial trace actor. And that one we'll come back to, but trace actor, what we're going to do is we're going to set up 2 points that we can position in space, and we'll trace between them. And then radial traces, we'll just do a whole spin thing going on so we can trace everything else around us. So that way we can see everything going on. And then within these, we'll replace the tracing function so that we can see how they operate differently. So within our trace actor, we're going to go ahead and wait for it to load. Oh, there it is. And one other thing we need to do, if you haven't already done this, Alex, do you know if you've done this?
Done what?
We need to change our AA method.
Oh, no. This is going to be on the default. We haven't gone in there and changed anything.
All right. We're going to change it to FXAA.
FXAA.
That way we can see the trace lines much more easily.
Yeah, as we turn on the debug, they come out kind of thin.
Well, it's not that they're thin, they're blended.
Yeah.
To the background, you can't see them. All right. So we got an actor. We're going to need 2 vectors. So let's go variable, change this one to trace start. And change this one to a vector. We'll do another one. Trace end. And because we're going to expose these, and let's give them a default value of 0. Are these relative? I can never remember that. Show 3D widget and show 3D widget, because I think they report
their relative location to the origin of the actor as opposed to their world location.
They show world, or pardon, they show in world, but they report local. Yeah. So we need to make sure that we remember to modify for that. So we'll do an offset of these on Y at -100 and 100. So come back up here. Trace start, -100.
In the Y.
On the Y, and trace end 100 on the Y as well. So that way, when we see these in the real world, now they'll be
just a little bit offset there.
That's fine. We'll just reset it. There we go.
There you go.
We have our trace start and our trace end. And now in our event graph, I'm going to do, my favorite thing to do is to make sure that we constantly are getting feedback. So for testing purposes, this is what I do. I do timer and set timer by handle, like so. No, not by handle. Set timer by event. Set timer by Yeah, the one that it selected the first time.
Yep.
Never mind.
Just gotta
Looping.
Delegate an event to this.
Yep. 3, and then we'll custom event. We're gonna call it fire trace. I mean, we could do this with
That says free trace.
it. Isn't that fire like in German or something?
Fry. It's Frie. Like, so I guess, I mean, that's probably
I mean,
in some language. I don't
Yep.
know.
and we connect our little red thing up here. Time 3 is fine. The default for debug on the trace is 5 seconds.
And of course, this is in seconds, not 3 frames.
Yes, thankfully.
I actually get asked that quite a lot. What's the time in? It's in actual time.
So we're gonna get our trace start and end. We are going to get our actor location. Get actor location. You can do a bunch of addition. So, plus vector. What's your vector?
Roger. We're not getting into that. We're not doing that one. Like, I know the entire airplane routine. We're okay. Stick to the Unreal.
All right. So now we have our start and our end, and now we just need to throw in a trace. So we have lots of traces to choose from. We are going to start by talking about channel traces. So line trace by channel. We're going to have a start. We're going to have our end. We're going to say trace channel visibility. Sure. Trace complex. Why not? No actors to ignore. Debug for duration. We can expand out here. We can show our trace color and our draw time and things along those lines. But really, that's it, right? Like this is our trace. Now what we need to do, of course, is, hey, what if we actually hit something? So let's break our hit result here. So when you trace, when this hits something, by the way, maybe we should back up just a little bit. So tracing uses physics, so literally phys-x, to run the traces, right? So it is attempting to trace against collision in the world. That means you can trace against actors with collision, skeletal meshes with collision, terrain, BSP, anything that ends up having collision. And for meshes specifically, pardon, static meshes and I believe BSP and terrain, you can do complex collision. So you can trace against this complex collision.
Yeah, because the terrain has that.
Yeah, it has actually a triangle mesh.
An actual triangle mesh that you're going to want to do that with.
Skeletal meshes you cannot trace complex against. You will only get the physics asset, which is actually really important if you're thinking about using things like get UV from trace. That functionality does not actually work on skeletal meshes. That only works on BSP, static meshes, instant static meshes, things along those lines. So when we hit something, we get a whole bunch of data back. It's a huge struct. We need to know if it's a blocking hit, if it's an initial overlap, time, location, impact point, everything.
Yep.
What we're going to worry about for right now, I'm going to worry about our actor. So we're going to say, hey, did we hit something? We're just gonna branch.
I mean, that's right. Yeah. That's,
just so we're not spamming.
That's just like a valid. It is valid.
Yeah,
check,
we're just
basically.
doing is valid.
Yeah.
And then we're gonna say if valid, we're gonna print out the actor's name. Okay.
Yep. And so you want to actually get the hit actor. There you go.
Get display name.
Yep.
There we go. Now if we compile this, and we look at our actor here, hit play.
You might want something that's
there. It is.
Oh, there you go.
Yeah, I need to make sure it's...
Yeah, turn on the visibility of those that node so you can actually see what you're testing here.
I wonder if it'll actually...
It's a little bit high up. It might not actually catch you. And actually, I mean, are you the correct channel for it to hit?
It should be, I would think I block visibility.
Oh.
But I don't know.
But you need to check.
So, let's...
Always double check your channels. Just because a channel is called something that makes sense for you to be on or whatever.
They're all just names.
They're just names.
It's irrelevant.
They are just names.
It could be 1, 2, 3, 4.
I call my channels really weird things, and then I forget why I called them that, and that's my own fault. But
well, maybe you shouldn't. Just throwing this one out there. Maybe you shouldn't do that.
There we go.
Just thinking.
All right, we just had to adjust the camera on the fly. That looks really nice now, though. I like it.
What? Nobody wanted the close-up of my hat?
No, they want to see your hat.
Oh, they want to see the close-up of the hat?
Yeah, it's a nice hat.
No problem.
No one cares about my hat. I see how it is.
You are absolutely correct. The capsule does not actually block visibility. So.
Oh, look at that.
Mind blown. Okay.
It's almost like I worked on support for a while. And I've been the guy that's like, but did you check the check boxes?
Did you check all the check boxes? Okay, let's go back into our little actor here. Let's make sure we are visible. Okay. Actor. Rendering, actor hidden in... Okay, so that's just not going to show. Fine. Oh, I don't need you. We will use a billboard. Billboard. Where's my billboard?
I was going to say not a blackboard, billboard.
Yeah.
Blackboards are for AI.
Yeah, we'll use a billboard, and we'll do something like this. We'll just offset it a little bit above the actual actor. And so we need to make sure that we move the actor around for a little bit, but that'll actually help us see what we're doing. And we need to go back in there because Ian probably... Yeah, hidden in game.
Yep, visible, but hidden in game isn't going to do you much good. Always check those check boxes.
Now we can see where it's at. So let's go ahead and let's move this guy a bit.
Oh, wow. Getting some good questions in here. Remember, you guys can ask questions in chat if you're watching live.
Really? We're getting good questions.
Yeah, we're getting some nice questions.
All right. So let's go ahead and let's make sure our trace actually goes through our box here. Looks like it's going to do just fine. And, of course, I shoot the box as I enter the playfield because reasons. There we go. All right. We got a successful trace going on. Now, over here is our start. Over here is our end. As we have passed through our box, which blocks visibility, we can see that we have a little red mark here. Mm-hmm. And I've kind of moved the box a little bit, and you can see that it continues on green as it goes to the box. This is letting you know, hey, I've hit something.
Yep.
This is where I hit it. And beyond that, the trace has been successful.
That's the success zone.
The success zone. We have successfully hit something.
Yes. Now,
visibility traces and object traces work a little bit differently when we start talking about multiple trace returns. So this is as simple as a trace as we really can get here, guys. Like, we now know that there's a box here. Mm-hmm. We've gotten that actor. We could do stuff to this actor. We could apply a force. Mm-hmm. We could do a bunch of checks.
I mean, we could just get it cast to it and activate a function.
Yep.
We now have a way of saying, this guy right here,
yep,
let's use him for something.
Yep. We know it's there. We know it's solid. We know it's on the channel that we're looking for.
Mm-hmm.
Great. Okay. Well, what if I want to know multiple things? Well, our first instinct is going to be, well, there's multiple. Line.
Yeah, multi-line trace?
Multi-line trace by channel.
Yep.
Cool. Let's go ahead and use this, right?
I like how you actually typed in this, like, a series of words you knew were vaguely correct, and it's still, like...
Yeah.
Yeah. It's just like line, multi, trace, and just, there you go.
Yeah, this is the one you're probably looking for.
It's good.
Yeah, the search stuff in here is actually pretty solid.
Yep.
So I'm just gonna rehook everything up here, guys. And then we're gonna have to make a slight adjustment here because this one returns a single object, or pardon, a single struct. This one returns an array of structs. So, of course, we're going to have to do something a little bit better here. We're gonna have to go through all of these. So, whatever. For each. And this time, we're just gonna avoid the whole branch thing. Gets really kind of out of hand if we do that. I'm just going to print out everything that we hit. Okay? And when completed, nothing really to do. Visibility, trace complex, ignore self, for duration, debug time. Okay?
Mm-hmm.
All right. Well, this seems reasonable, right? This is exactly everything that I would have done. And then we need to make sure that we hit multiple things. So let's expand that out. And hey, why don't you
just come hang out over here?
Why don't you come and hang out with us? Okay.
There you go.
Why don't you hang out right there?
We're all going to be friends over here, Mr. Box.
Look at our trace. Okay, maybe it's a little off. We'll do that.
It's close enough.
And let's see what we get. Huh. Editor cube 11. We are not getting a secondary hit here. The reason for this is that channel traces actually don't return all blocking hits. If you want all blocking hits, you have to use an object trace. Channel traces will return all overlaps and then the first blocking hit. So if we wanted this to work, what we do is we select our box here. This is useful for things like, the concept here is useful for things like, oh, I have bushes in the way, or there's a glass pane in the way of me seeing something. I need to know that the glass is there.
Yeah.
But I don't want to be able to, quote, see through something. That's the concept of kind of the visibility channels, right? Like they're meant to kind of mimic in your mind like how you would see something.
Yeah.
So we'll just go ahead and we'll see how this works by making our little actor here, our cube. Let's see, collision. We're gonna turn on custom, and we're gonna have it overlap visibility. So when we come back and Ian shoots it again, because left clicking in.
Yep, that did not help. It just hurt.
There we go.
There you go.
We end up with an initial overlap, which we return editor cube 10, and then we end up with our blocking hit, and then beyond that, there's nothing, of course. So if you wanted to know, like this is great for like hunting games, or actually we're going to talk a lot about tracing, and really what's going to come up is like shooting stuff. Yep. Like you want to shoot stuff with laser beams. Yep. Like okay, puzzle games with laser beams are cool too, but I'm just like, I think railguns. Let's do this. This is really easy.
I think that's like the most classic thing is when people think about a simple line trace. It's just that goes back to, well, it's just, it's like a bullet, just and then whatever it hits activates a little pop and a sound and all the things. Yep. So yeah, that makes perfect sense.
And if we were to look at this, like from the aspect of being a railgun, well, visibility is a really bad channel to use.
Oh yeah, no.
Camera's terrible too. So what we would do is we just create our own channel.
Yeah, we would create like a shootable channel.
Yeah, which should be, I believe, under project settings.
Oh yeah. Project settings, collision.
Ooh, wow, it's okay.
Oh yeah, no, we have a lot of nice settings in here now.
Yep. Okay, so let's go to
collision. It's alphabetical.
And we have our trace channels here. So we're just going to create a new trace channel.
And in the presets, I think you can also take a look at those if you want to like alter them.
Yeah, if you wanted to
remove them, like whatever you want to do.
Well, I don't think you want to alter any of them.
You don't want
to,
but you can.
But we'll call this new channel railgun.
Yeah.
And by default, what do we want everything to do? Now we're creating a new thing. We're relatively small, in our project here. So what can we do with this? Well, we can have everything ignore, block, or overlap.
Probably overlap.
We'd probably just have everything overlap to start. And then we'll build the actors that we would go through and be like, no, this thing blocks the railgun. So this thing, whatever channel this would use, like all of our objects are now going to overlap it. And that's great, because what we can do really easily is now come back into here, hit compile real quick, and it's not going to show because reasons.
What'd you do?
Oh, it's just being hinky. Do I have to close it and reopen it? Save it, maybe.
Oh, did you actually save the new channel that you made? There it is. Okay.
It doesn't automatically update. You got to kind of kick it.
You have to actually refresh the page to see the new changes. Yep.
So we'll now trace against railgun, and this is multi-channel trace. So if we come over here to our actor, we expand our collision presets again. Come on now. Once again, they're not going to show, but if we select something else, we'll see that we have a railgun overlap.
Oh, there it goes.
Overlap.
Yep.
Overlap, overlap, overlap. And then, pardon.
I'm sorry.
Like I said.
It's okay, buddy.
Like I said.
We all feel bad that you're ill. Thank you, though, for coming out here.
Yeah.
I'm gonna throw this one out here. He's not even supposed to be here today.
I'm on vacation.
He's on vacation. He did this because he likes coming out here and talking about this stuff. So thank you, Ian. You're really awesome. So yeah, now we've got multi-trace here. Now I'm gonna throw this one out here. So I noticed the way that you have this line set up is the exact same way I would set up a fully automatic weapon. It's just a timer, and instead of setting it to 3, I'd set it to 0.5 or whatever.
Absolutely.
So.
Yep. And well, you would do something like a while trigger held kind of deal. Timer is firing. And then you terminate the timer when you let go of the trigger, right? What are you smiling about?
All right. No, don't make him have coughing
don't
fits. We already
make me
talked
laugh.
about not making Ian laugh.
Oh man, making me laugh.
Okay.
All right. So that's great. And now let's talk about object traces.
All right.
And we'll go ahead and replace our multi-line trace by channel here. And we'll do a multi-trace by object. Multi-trace for objects.
Aha.
Okay, so...
That's all of them.
Oh, no.
Yeah. That's it?
I did box.
Oh, not multi-box. No.
Not yet. Multi-trace line for objects.
I always end up calling any events that go to a multi-trace multi-pass. So that...
You're trying to kill me. That's what
Multi-pass.
That's what you guys are trying to do.
There you go. There you go. All right, so now you can just, replace all of those connections there, and everything just plugs in the same.
Except we're going to have a whole other thing that we need to do.
Yep. Because now we have to decide what's the object types.
This will literally not compile.
Yep, because it's like, what object types? You need to make an array of things that I'm able to hit.
Well, what are these things? Now, object types are the object responses. So world static, world dynamic, pawn, physical body, physics body, vehicle, destructible, projectile. These are our standards.
And just like the visibility trace, just like the traces, the object trace responses are all just completely arbitrary, whatever you want to call them. And that's, I guess that's the word I'd use, is arbitrary to a degree. Like, you can get thing,
there we go.
It's whatever you want to call it. I know I got a couple questions coming in through chat too that were just, what's the camera channel do? It's like, it's just a channel called camera. We've probably attached it to a lot of things that cameras do.
Internally, we have rules about
like naming conventions.
What is the camera channel normally used for? And you'll find it automatically used for spring arms.
Yeah.
Right? Like, we automatically choose the camera channel, and a lot of things do or don't block the camera channel based off of that. There's a lot of internal logic that we've used, but it's completely arbitrary.
Yep, it
worked for us.
These are naming conventions for variables. Same thing, except for these are just, this is X. You can pass through X or not pass through X.
Yep.
And that's it.
So if you want to make one of these really easily, you just go ahead and hit make. So pull off your little array thing there, say make array, and then we can put in some stuff. So what are our boxes? Our boxes are object type physics bodies, okay? So we'll just do physics bodies. And those are the things that we want. We'll do physics bodies, compile that, and we hit play again, right click instead of left click, come over here, and there we are. We're returning all of them. Now, when we look at these block that object response channel. Plus they are them, right? So we're finding them, they block it. There's no overlapping going on here. It is simply, this is what I am. Here is my response to you.
Yep.
And so really, really simple to find everything that you want using this kind of trace. But it is dependent on you wanting to find something very specific. You could expand this. I mean, it's an array, so we can just be like,
there's quite a few channels you can add into it.
Find everything, right? Like,
yep.
Remove empty bin, remove that one. And so that's kind of like the basics of tracing. We're tracing between 2 points, we're finding everything in between it, or we're finding one thing between it. And then what we decide to do after the fact, like, we're just printing stuff out here, right? But now we can move them or explode them, or whatever we decide to do for game logic goes beyond here. We're not going to really get that deep into it because shorter stream, and we still, I know the big question that we get asked, and I really want to delve into it, is how much of a performance set are these things?
Oh yeah, that's actually, you know what? That's a lot of the Q&A is.
Yeah, a lot of Q&A is probably like
the Q&A is how heavy are things?
How heavy are these? Well, we're gonna find out.
All right.
But before we do that, of course, we're gonna talk about the different shape traces.
Mm-hmm.
So, this has been a multi-line trace for objects. Let's do I don't know. Let's do multi. I mean, we have the array set up. Let's do multi-sphere.
Multi
objects. And I'm sure you guys can guess what this is going to do, right? Like,
I think it's best if you very clearly state exactly what it does, though.
It is going to trace outwards along a line.
Yep.
But that line is actually going to be a volume. It's going to look like we trace a capsule.
It's not
into space.
It's not entirely unlike like you had like a perfectly straight like thin rod and you took a basketball and just like threw it down that and just like it slid down it and everything it hit, that's what it returns instead.
Yep.
So it does create just some volume to it. Now, I also use these sometimes to do like a quick area check where I'll just be like trace like like a radius, right? But only like move a part of.
That's
like
kind of the trick, right?
Tiny half vector or something, and then it's like what's around me basically is the check.
Yep, and it's far more effective to do that than it is to check for overlaps. Overlaps for whatever reason. Now, actually, I take that back. I don't know if Ori's been working on the overlap stuff, but I do know that overlaps in the past have been pretty unreliable. Traces are incredibly reliable.
Yep.
I mean, if you go look at the turn-based strategy game that I worked on for a little bit up on the
Learn tab.
On the Learn tab,
yep.
You'll notice that the lights in there do a sphere trace to figure out what's around them, and they're looking for you so they know to turn on and off shadows.
Yep.
But there was no way that was happening through overlaps. None whatsoever. They were just so unreliable, and the effect was just completely lost. But could be different now. Like I said, Ori's been doing a ton of work on the system, and every time we come back and we look at it, it's better and better. So the one thing that we need to change on our multi-sphere trace for objects is we need a radius. 0 is boring. 0, I think actually 0, I don't think it returns anything.
No, if you
it works like a line. It actually works.
Oh, it does. I thought that you had to give it at least something.
Nope. 0 radius will actually work just fine.
Huh.
Let's give it a 50 radius.
That's nice that they clamp that.
Yeah. Right.
Yeah. Okay.
So this is gonna be huge.
Yep. And don't forget to
bloop.
There you go. Visualize it.
There it is.
So yeah, you can see it hit something in that first trace.
Yep. It only shows like weirdly the sphere on like the last blocking hit for whatever reason. But you see all of your hit locations right there.
Through those dots,
yep.
Yeah.
Now let's raise this up.
All right.
So now that line trace, if it was a line trace, it should miss. But this is a sphere trace. And sphere trace don't care. As you can see, sphere trace has successfully detected the boxes, detected them along the edges there, and we can, successfully say, yeah, all right, trace worked. Really useful if you have a bigger weapon or you need to know something of a certain volume can fit through another space. And in fact, for characters, we have a very specific trace called the capsule trace, which we'll show next.
Yep. Which is designed to help you with character...
Trying to figure out...
level design, character development stuff.
Yeah, whether or not a character can fit through something because of the capsule that we use.
Yep.
So these are interesting, and I'll show you why. Yep. So we'll do capsule trace. Yep. Give me multi-capsule trace by object. Sorry, resisting coughing.
See.
Must resist.
It's an infectious laugh you have there, Ian.
Is that a flu joke? Is that a flu joke? What are you doing to me, man?
I'm hiding. That's what I'm doing.
All right. So we got our capsule trace here. It requires a radius and a half height. Well, what's our dude? Our dude capsule E is 9655. Oh, wait. Which one's which? Half. Okay, those are backwards. So 55, 96. Object types. Sure. Trace complex. Duration. for our debug.
Mm-hmm.
Compile that out. Now this should be really,
Yeah, this is going to look a little strange compared to the other one, yeah? Because it stays standing up, right?
Mm-hmm. So you can see that it's like, oh, okay, well, this is the last one it hit, so it's drawing the debug one there. You can see right there it hit on that edge. So we know that this is a little low for our guy to get through. But if we modify this, let's do this. Let's kind of just do it straight up and down there. Actually, let's give it a bit of an angle.
Mm-hmm.
Like that. We hit play, come back over here. You can see the capsule trace works just like the character's capsule. It attempts to stay upright. Attempts. It can't not be upright.
Yep.
So that way, hey, you need to know if you can fit through a door?
Mm-hmm.
Hey, there you go.
Yeah, this is really useful if you want to like predict where the character can fit like ahead of you. You could do a capsule trace ahead of the character and go, oh, he can fit through that area. So it's fine if he does a dash forward, but if he's not able to, then give him like the noise or whatever.
Yeah, right.
Etc. And you could also do this. You saw how you can adjust the height through I guess the radius settings of the capsule to match your character tall or like while crouched. So if you were doing something like, for example, I would use this for if my character could do a slide, whether or not he would attempt to slide into something, if he would just get caught underneath it and then create errors. So this could be great for preventing bugs and working on movement-based mechanics.
Yep. If you didn't want to use nav mesh, you would probably have some method of figuring out where you can and can't go. This would be a pretty solid place to start.
All right.
Okay, and finally for shapes, we got box. Box is interesting. Multi-box trace for objects.
Mm-hmm.
Now remember, the reason I'm using objects is it's just a little easier to set up, and it shows everything that it hits without too much muss or fuss. But we could be easily doing this with channels and then having some stuff out there that overlaps. So start and end, and now we have a box, which is half size and orientation. So orientation is rotation. Just so we show it working, let's do 33 and 12, I don't know, some small degrees. And we'll make this box half size. Let's make it like 25, 25, and 75. Something like that. Oh, no, that's going to be huge. We'll do, why not? I mean, it's half height. That just means it's 150 units. If we show this one off again. Oh, didn't turn on.
Helps.
Duration.
Helps if you turn on some duration. Otherwise, it just blip.
Wow, it's not even there.
Yeah.
I mean, I turned on no debug.
Oh, well, then that's that.
There we go. There's our rather interesting box trace. Now, you're probably wondering, what is this? Yes. Okay.
Looks like someone punched a tesseract.
So look right here, right? Here's the bottom of the box. There's the top of the box up there.
Yeah.
And there's the long side. So we've rotated it. And then it's connecting all of those lines down to the end of the trace. Probably easier to see on this top edge right here. So there's the top edge all the way down to that top edge. And then it shows us where we've collided down there. So it's rotated in space, but it gives you a rather interesting way to check. You know, actually, I have no idea what I'd really use this for outside of, like, you need to know something, the bounds of something is going to clip through, right? So you want to make sure that your box is oriented the right way and it clips through everything correctly, right?
Yeah.
So that,
I mean,
is really all the options that are available for tracing.
That cube just, I can't stop looking at it.
It's not a cube, it's a box.
Yeah, it's a series of things, isn't it?
Well, I mean, it's showing you all the traces.
Wow.
Right, here's one box. There's the other box.
Oh, I see it now.
There's the final box.
And then they have lines that kind of connect up.
Yeah, they connect all the corners together.
It was doing that thing where it has like weird lines
right.
and depth, and my brain is like, what am I even looking at? Okay.
Right.
Okay, now I understand.
Here, I'll move this out of the way.
I see. Yeah, no, it makes perfect sense now.
Now,
Yep.
We just have the 2.
Yeah, and then it has the lines going between each of those 8 sections.
Exactly.
Gotcha.
So we're trying to find physics bodies here in this space, which I don't respond to that channel. So there we go.
Cool.
Now I believe that's it for the types of traces we have available. These are all available in single and multi. And the reasons that you would use single versus multi is like, you just need the first thing that you're going to hit. Multi, you need to know everything within a line. Channel, if you need to know, if one thing along a line is blocking you, or if you need to know if there's a number of overlapping things for that channel. So what we'll do now is we'll see if we can stress the system a little bit.
All right.
Because a single trace is nothing.
Yeah, it's nothing, but we need to talk about costs and how much this thing's going to tax your system.
So we'll do a radial. I'm going to need a billboard. Going to need a billboard. This is our radial trace actor that we created. Make the billboard our root. We're not going to do hidden in game. We're going to have our little raptor head. And what we're going to do, this is something I do actually quite a lot. We'll do event begin play again. We'll do timer by event. I don't need you guys. And then we'll do
custom event. Same way we set it up in the other place.
Yep. Fire trace. This one we're going to fire. Now we're going to fire at the same frequency. I was thinking maybe we'd fire a little faster, but we need to make sure that we can actually see it in the profiler. Okay. And we'll set up some variables to make it easier to tweak stuff. So we're going to say how many traces. So we'll do number of traces. And we'll make this a integer. We're not going to have any half traces. And then we're going to need a for loop. And we're going to define first index, last index, this -1, just because of the way my brain works, starting at 0 and working our way through it.
Yep.
And we're going to need our actor location. Get our actor location. And we're going to need an offset. So we'll call it trace distance. This one will make a float. And now we will come up with a rotator based off of this bit right here. So we have a number of traces that we're going to do. We have the index that we're on. So really, what we're going to do is we're going to do, I believe it is float divide int. Does that exist? Nah, it's just float divide by float. And then we'll just do
convert int.
Yep. Number of traces.
Nope, you have to do the get first and then connect it, and it will do the auto convert for you.
Fine.
Yeah.
Fine.
But I believe that there's actually a feature request to be able to do that, where you do the get straight to the node and then convert. So.
So we'll do number of traces into our 360, and then we will multiply this by int times float, our index here. So this will give us a number of degrees, and then we'll do a make rotator. Actually, hold on, do I need to make? Yes, I need to make rotator. Make rotator, and this will be yaw. And then we get an x vector from this. Make x, or pardon, get rotation x vector. All right. So this will get our x vector, and then so this will be a normalized x vector. So if it was nothing, or if it was just, it'll be something like 0, or pardon, it'll be x and y, because we're on yaw. So if it was pointing completely down x, it'll be 1 on x, or -1 on x, or 1 on y, -1 on y, and everything that's in between there. So what we're going to do now is we're going to multiply that by our trace distance. So multiply by float. like so. This will give us an actual vector in space, and then we can say, hey, let's add that. It'll be local to our, actually it won't be local, it'll be from 0, but we'll add that to our actual location, like so. Hey now, don't be like that. Give me that. Give me that. Like that. That'll offset it from our actual location, and then now we can actually, all that math later, let's do a trace of some sort. Let's start simple. Let's do a line trace by object. Plug that into our loop body here. And our trace start will be our actor location. Our trace end will be this stuff.
That's your offset.
And we will do for duration, for object type, make array. World static, we will do physics body, I believe it was.
Yep, for the cubes. Yep.
And then we are not going to do anything outside of this. We want to know kind of like, I mean, there's a cost for the math here, but we'll see the entire cost for this function. It's actually really tiny. Like all of this right here is actually nothing really in the grand scheme of everything. So we are going to just simply test to make sure this works. So compile, save that, and actually, why doesn't this save? Ooh, wrong button. No, what are you doing? Save.
There you go.
Let's put this guy in here. We'll do that. Actually, we didn't actually give him any defaults. Let's do that real quick. Default number of traces, 36. Sure.
That's a lot of traces.
Trace distance, 500.
That's a short distance, though.
Yeah, it's not all that far. Hit play.
It's like a shotgun of line traces. Yeah.
There we go.
There you go.
So now we have a lot of traces. Let's get rid of this guy here. We don't need him clogging up our mix here, do we? But we can come over here. Let's expose both of those. And we never have to come back in here again until we want to change this. Like so. Save it again. Select, reselect. Number of traces.
Are you trying to tax the system?
360.
There you go.
Distance, 2,500.
Sure, why not?
Play.
Multiply that 10 and 5 times, why not? There you go.
There we go.
Now this thing knows about everything going on in the level at this
Yeah,
point.
no kidding, right? It's like, I found the boxes.
I know everything about these boxes.
So let's do a stat FPS real quick. I'm pretty sure as I stare at this,
Yeah, we're running around.
we're not going to see
It's like 60 there.
any difference whatsoever, even though we're kicking out a ton of line traces.
Yep, even when it's kicking off, we're not even seeing it really jump too hard.
No, it's not doing anything. But this isn't useful.
No,
This
you want more.
This is bad data.
This is just FPS, which doesn't
Right.
really tell you anything.
And really, honestly, we could make it go faster by just simply, not showing the line traces. So if we turn that off.
Yep. Oh, but I can.
Well, yeah, we're not going to see anything, but now, I mean, most of our
Look at that.
costs
We got an
is
extra 10
literally
FPS.
from the
It's just
drawing of
literally
the
the
lines,
drawing of the lines.
right? Like, there's still no perceivable hit for this. But that's not, again, we don't actually know the cost of this just yet. So we've done this before. What we're going to do is we're going to turn on the ability to use the session front end.
Mm-hmm.
So we're going to go into our advanced settings here. And we need to find, there is a thing in here somewhere that lets us set launch options.
You can use search. You could search launch options.
Yeah, play in standalone game is what I'm looking for. And we need to do, oh man, did I just forget? I think it's dash messaging. I'm pretty sure that does it. And this will allow the session front end to communicate with a standalone. And then we will we will play standalone game. Yeah, sure, save selected. We're just going to let it load up real quick.
Mm-hmm.
And then we're going to close it. And then we're going to come back and... Yes, thank you for letting me know about my...
We need to update the
drivers, apparently.
Apparently, yeah. Yep. It's always something to update on this machine. Oh, wait. We're over on the wrong screen.
Yep, I'm bringing it over.
There we go.
So, here's our game.
Can Can we alt enter that?
We don't want to.
Oh, okay.
So you know our traces are running here, but we can't really see anything, but that's fine. Alt F4.
Mm-hmm.
And what we need to do now is we bring up the session front end. So developer tools and session front end. Session front end. We'll go to our profiler and we will hit play again. Standalone instances. Yes, thank you for my driver being out of date again. My sessions. Gotta wait for it to load. There it is, my sessions. I'll bring it over here in just a sec.
Well, this is the more important part, is the actual seeing
Yep.
of the session. So yeah, we've opened up session front end. We've done the drop down on the left for
Yep.
my sessions, play,
now we need to
standalone
do-
game.
We
And-
need to do data capture,
Uh-huh.
live preview, data preview. Just turn all that stuff on.
Yep, and we've already got it running on the other monitor over here, the standalone
Yep.
play and editor version,
Yep.
which you can see now in the corner.
Yep, it's not doing anything.
Yep.
Well, it is. I mean, we're firing those traces, right? So we're just going to let this run for a few seconds. You can see spikes in there, but the spikes are from me moving around the window. I'm going to go ahead and kill the session, and then we will be able to kind of peruse what we've done here, the madness.
Yep. So you wanna
I
like
believe we need to turn off. I always forget to do this wrong. I think we turn
live
off data
preview?
capture.
Oh,
I always screw this up, and we always end up having to go back and redo this.
live.
No. Yay! Okay.
Okay, cool.
Okay. Sweet. But it's still not.
You have to.
Do I turn off live preview?
Yeah, I think it's live preview that's causing you to stay to the front.
Okay.
Because it's live,
Woo!
and therefore the live one wants you to be on the most recent. So
Yep.
yeah, turning off live preview will actually let you scrub backwards.
Yeah. Okay. So. Yay! We didn't have to restart it for once. Okay. So. This tells us a lot of things right now. Let's ignore these big spikes for a minute.
Yep, that's where you're messing with stuff.
Yep. Let's look at this section right here. As you can kind of see, we have our game thread here, and our game thread really didn't do much of
It's
anything.
a little bit hard to see. It's so small.
I know it's so tiny, but I don't think there's any
Can we
way.
get some zoom in action for these lines up top? It's a little small.
It's very tiny. So
Just
tiny.
want to make sure the audience can see everything.
Yeah.
Whoa,
Oh, the fifth.
that's a little
doom.
better. Yeah, wow. There you go.
Okay, so this says right here our game thread, and it's showing our mins and our maxes and our averages.
Mm-hmm.
Really even hard for me to see, but it seems like it's saying our min is like 13.92. Our max was a lot, but that doesn't count because I was moving the window around. And so it wasn't bad. But now we need to figure out, well, what did our actor cost? Well, let's find them. Let's see, it was radial?
You tell me.
Yep. So radial trace actor.
Oh, that's right. That's what you did end up
Yep.
calling it.
So we actually have the function calls for there. So execute ubergraph. Oh, fire trace. Hey, the one that I want to know about. So fire trace and all of its glory took a minimum of nothing, took an average of 0.02 milliseconds, and a max of 3.802 milliseconds. Probably while I was dragging the window around.
Yep.
So
That's the
for
maximum. So that's a
100
little bit of a lie.
Yeah, it's a little bit of a lie. Well, it's not a lie per se. If you were looking for hitches,
Yeah.
like, okay, what caused that hitch? Was it me? Was it something else? I don't know. The minimum here is like really ridiculous.
Mm-hmm.
So we can graph that. It's not going to really show us anything because it literally costs nothing.
Oh, there's that tiny little spike.
Tiny
it's
little
super
spike
hard
right
to see,
there.
but it's so small. Like the arrow itself covers it up mostly.
Yeah, this is like the game thread right here.
Yeah.
And then here we are doing our 100 little traces, our
So
our
small.
360 traces, 100 traces, and doing absolutely nothing. Okay, well, let's make a dent.
Mm-hmm.
There's no fun unless we actually try to do something. Factor of 10 or factor of 100?
You know what? More zeros equals more better.
Factor of 100.
That's always been my motto.
So we're gonna go ahead and give us another session here. It's going to pop up on the other screen.
It's going to tell you that we
complain
need
about
to
my
get
driver again.
the driver update.
Update your Titan
It's an
drivers.
unnecessary update, so that's why we skipped it. But now it seems necessary because it keeps being
Yeah,
like,
it keeps
hey,
on warning.
hey.
Shift F1, or pardon, Alt Tab. Session front end over here. Give me my other one that's currently running. Give me data capture, live preview, preview data.
There we go.
Now we're seeing some actual.
Yep. Oh, and you
Now
can
we're
see
seeing
the-
some dents.
Ooh, wow, that's a little bit of a bump. You can actually feel the hitching just watching it on the
Yep. On the other
live
screen, it's
tick
literally it's stopping for about 3 frames.
there. Oh
Okay,
yeah, you
let's
can
turn off data
feel
ca-
that hitch.
No.
Nope.
Turn off live preview again. Wait for it to catch up on data.
Because it's hitching so much that it's still catching up on its own data.
Yep.
That's our bad.
But now we can see that one.
It's still coming in.
Yeah, it's just the data coming in, I think.
Wow. Wait, are you sure that it's okay? Yeah, you did turn off live preview. It's
No,
That
well, okay, let's kill it.
all right. There you
Whatever.
go.
Okay, we've it still has radial here in our search. Should be the second one here, I believe. Fire trace. Fire trace has cost us an average of 8.435 milliseconds. That is a lot of time.
Yeah, that's more than 10 times what it used to cost. Even though, I guess that makes sense. We did put it.
Well, it's also the amount of, comparatively to what we were hitting to what we are hitting now, the amount of data that we're returning. And this is a single trace.
Yep.
You do a multi-trace, you do a shape trace. All this goes to the roof.
Oh my goodness. This is this is
So-
the lightest you can do. So
But hey, let's be clear. We are doing 36,000 traces.
yeah, not 3,600, 36,000.
36,000
There's-
traces.
I can't think of a single instance in which a game would need to do that.
There is no instance in which a game would need to do that. So, we were talking.
Please don't make that game. I said it and then I realized.
Yeah, right.
I know these guys
Challenge
watching the streams
accepted.
exactly what they're thinking. Challenge accepted.
Challenge accepted. So we were talking earlier, and I remembered something that I got a chance to talk to one of the AI guys out in ECGC, and we were talking about the AI for Uncharted. I believe it was Uncharted 3 on the PS3, and how they did sort of the sneakier sections where the AI is looking for you, and you're in the tall grass or whatever. And it turns out what they do is they do a trace from every one of Nathan Drake's bones to the eyes of the AI. So basically, center of the AI's head and all the bones in Nathan Drake's body. They say, okay, well, can I see any of them? How many can I see? Are they important? Things along those lines. And it's really fascinating when you consider how many bones there are in his art. It's like, it's not a small amount,
Yeah.
but still, it's not 360 even with like 5 dudes on screen.
Yeah, but that's
So still it's super cheap
yeah.
comparatively to what you get out of it.
And I'm sure that they scale that too. Like if he's a certain distance away, they just
yeah,
do like
absolutely,
a single trace. But as they get closer, they do more per bone
Exactly.
traces.
I mean, you can definitely blow this out of proportion. You can blow this out of the water.
it makes perfect sense though, because you want that precision of like if they see a foot versus if they see a chest, that they're gonna know like maybe a foot.
Maybe a foot.
You can get away with hiding from that. But if they see like part of your torso, then clearly they saw you.
Yep.
Oh wow, okay, I gotcha. Yeah.
Yeah, that's pretty brutal right there.
I really wonder how they do it in The Last of Us then, because if Nathan Drake does that, then that
It's
would
probably
be
something very similar.
Yeah, that would be the next example of like really strong AI with really good.
Well, at the same
senses.
time, aren't the clickers supposed to be audio driven, not visual driven?
But audio channels are nothing more than these kind of channels as well.
Right, but your fingers don't make noises.
What?
Right? Like, think about it. Like, the amount of noise that they got some good hearing.
Yeah. Okay. I guess.
They're hearing my joints grind right
Oh,
now.
like if they see your hand sticking out versus
Right,
if they hear you
like,
making.
I mean, they probably wouldn't need as many traces to
I
deal
was
with.
I was thinking of the humans in it, but okay. I mean,
Well, yeah, no, the humans in there probably have...
we're getting off topic.
Well, no, not really. I mean, it's... looks like we have that... So it's taking about 355 milliseconds when it actually traces all of these. So, not the best. That's what? Is that 5 frames? 6 frames? 7 frames. 7 frames, I think, depending on what FPS we're trying to run out here. So between 5 and probably 5 and 7.
That's brutal.
So, yeah, let's not use 36,000 traces.
It's not.
But at the same time, I wonder. Let's do. You know, we got to do one more. We'll just take it down one. Actually, no. Let's brutalize it further. What shape trace should I put in here?
Let's go with that capsule one.
You want to do a capsule trace?
Yeah, put in a capsule
Okay.
trace. So we can really see.
Should we do multi-capsule?
Yeah, let's just really ramp it up, like maximum, like so.
Maximum ridiculousness.
So what we're trying to show you here is that
There are differences in costs between the shapes.
Yeah, there are differences in cost, and it mostly comes from the complexity of shape, how much you're actually tracing, like if you're doing multi-trace or single trace, how far you're tracing, the amount of traces that you're doing. It really comes down to how you set up your traces. But yeah, there is like the absolute minimum is like a super short single line trace between 2 points with a single hit return.
We'll do that.
And that's going to be your smallest versus your largest can be anything that you can fathom as far as making a really complex shape and then just doing tons of them.
Okay.
All right.
Come on, tell me one more driver. Yeah, there we go.
All right.
It's not that this driver's out of date. It's like there have been known issues with this driver.
Oh no. Don't say that. There you go. Whoo!
Oh, I forgot to actually set up the capsule.
Oh.
Alt F4. Alt F4.
Every time I Alt F4, it takes me right out. Come on.
I don't know.
It likes you. That's what it is.
What was it? 5596? I think that sounds right.
Mm-hmm. Why not?
And let's just do selected viewport.
Bloop. Woo, that jumped down to like 40 from...
that's all rendering.
Yeah.
Right, we're rendering a ton of additional lines here.
Yeah. Goodness.
I'll be
and just depending on what you're looking at, it also seems to change based on, because it has to render up more. Yeah, it's just crazy.
Look at that. Look at that pattern right there.
Oh, gosh. It's like fractal art because it's layering so much. So, yeah, what we've learned from this is that it's crazy expensive to do that.
To render them. Let's be clear. Just rendering them. And if we don't render them, I am seeing no perceivable hit. No, wait. I think it jumped. It jumps to 20 milliseconds.
Oh wow!
When it fires.
Yeah,
you can just barely see it flicker up to 2.
So yeah, that's like a lot of rendering that we're doing there. That's the problem.
Yeah. Well, that's fine. I mean, that's what we're wasting our time on our game, right?
Yep.
Let's go ahead and did the session front end close down, or is it just hidden over here?
It's just hidden.
There you
go.
Session front end, and we will play standalone. Yeah, sure, save. Yes.
Cool.
Tab.
Mm-hmm.
Data, live preview, data preview. Okay. We're just profiling, got some data. Data capture off. No. Live preview off. Over here, click into here, closing it down. All right. Here we go. That's me messing around.
Mm-hmm.
We still have our trace actor stuff down here.
Yep.
And we have increased to 0.176 milliseconds from, what was it, 0.05? So a substantial jump. So the first test that we did was like, 360 traces as single lines.
Yep.
This is multi-capsule.
Mm-hmm.
And we've increased by a lot, but really only 3 times? Hold on. Yeah. Oh, no, I think it was actually 0.02. Can I actually get back in there? Cross your fingers. No, data's gone. Data's gone, and probably the data's gone. Yay! Oh, wait, hold on. Data preview? Nope, data's gone. I have to go repull it back up. But we are at 0.17 for increasing to capsule traces, basically. So if it was at if it was at 0.05, it was about 3 times increase, actually closer to 4. And if it was 0.02, if somebody can remember, then yeah, it was a substantially larger increase. But we're also talking about this in milliseconds.
Mm-hmm.
If you have, call it 2 milliseconds for your AI calculations, that's not really all that bad. That's not even a chip out of your budget for AI.
Yep. And this is why budgeting is so important.
Right. Exactly.
Yeah.
So, all right. What other questions we got here? I know we got a list of them piled up.
Yep, we do. All right, I'm making a note here. Cool. At about that time, Q&A.
Mm-hmm.
So Q&A. We have many awesome questions that come in from chat live. If you are ever watching us live on Tuesdays or Thursdays at 2 p.m., you can ask questions live too.
Yeah.
So if you're watching this archive on YouTube, that's how it's done.
Mm-hmm.
Had a few people on YouTube ask, how do you get questions into us? So that's how.
Or you do it on the forums beforehand.
Or on the forums beforehand. That is absolutely correct. Forums.unrealengine.com. You can come out there at any time. Whatever's on the events section, that's going to be our upcoming streams. You can ask questions there, and hopefully we can answer them on the stream. So the first ones up are from the forums. Frank Tech has a few questions for us, and these are kind of, they're worded a little bit without context, but I think we can kind of derive context from them. Question 1. Limitations of fast-moving spaceships tracking high-speed objects ahead. Special CCD tracing needed?
You can't.
You can't?
You can't.
Yeah, because it has to be, you have to have the exact vector of each hit point beginning and end.
Traces don't simulate through CCD.
Mm-hmm.
So it's you're there and then you're there, right?
Yep.
There's no here. You were never here as far as the trace is concerned.
Yep.
Because you were here, I fired my trace. Then you were here, then I fired my trace. Even if you're doing it on tech. So how do you get around it?
Mm-hmm.
Well, there are a number of ways. Stretch your collision. That's actually, if you watch anything about like really competitive CS, Counter-Strike.
Yeah.
They tick rates, huge thing, and people get jello. Their collision boxes get jello-y. They come around corners and things like that.
Oh, weird.
It's really weird, but it's how you would do it.
Mm.
If you really have to have fast movers, you need to make sure that your collision extends beyond a certain point.
Yeah.
Really easy to modify. Really, probably what you want to do is you want to have a stretchable sphere capsule or something that lets you know potentially there was a hit, and then work out whether or not you really wanted to be hit. Like, would have actually been there, what's the time frame there look like, things along those lines. Another way potentially to handle that is if we're talking about laser beams,
mm-hmm.
and you're holding the laser, right?
Or you hold a gun that holds a laser. If you're holding a laser, your hand's burning off.
You're shooting a laser,
mm-hmm.
and the laser's cutting in front of you. Fast-moving object goes from A to B. You're not using a trace at that point. Just have a collision object there.
Yeah.
Like just a capsule that extends the length of your laser. And now when you
get that
collide with it,
overlap,
because
CCD on overlap, because
will
overlap
totally
does
do that.
use CCD.
And then you're just like, oh, bzz, and done, right?
So
you've
in that
lasered
case,
the dude.
So in that case, it's like skip the whole tracing through shapes entirely because you want CCD because it's moving so fast, and just use
it's not
an invisible shape.
It's not a projectile.
Yeah.
I mean, it's a lightsaber at that point. Right?
Yeah, I mean, that's true.
I mean, that works out really well.
Yeah. Okay, cool. Next up, Frank Tech again. Multiplayer considerations, tracing differences in single player versus multiplayer, origin rebasing, which I guess is kind of the jello-y shape of collision that we were talking about there.
Yeah, there are ways that you can, like we're talking about, jello-y shapes to make up for lag, deciding who has authority. That's oftentimes a real pain. Because you want your insta-hit weapons to feel insta-hit.
Mm-hmm.
But if I can see you, who do you give the advantage to?
Yep.
This is a long-standing argument, and it depends on your game. It seriously depends on what kind of feel you're going for.
That one comes down to mechanic decisions, I take it.
I mean, a lot of really good stuff on Unreal Tournament, PlanetSide 2, a bunch of shooters that handle it in different ways. That you give the advantage to the person coming around the corner, right? If I'm standing there and you come around the corner on me, I don't see you for however long lag is.
Oh yeah.
And now, who has advantage? Well, you obviously have advantage, so does it really matter that your weapons are insta-hit? Does it matter that the server has authority in that case? Not anymore, right? Like, it really doesn't matter because, yeah, it's interesting. So that's something well beyond what we're talking about here.
Mm-hmm.
What else you got?
All right. The next thing here, tracing based on where the player camera is actually looking, equivalent of LOS triggers in UDK. I mean, that's just taking a line trace directly, like basically taking the forward vector of a camera and
I don't
then
think we have
running down that, essentially making. I've always done that with a custom solution of get forward vector of camera and then like multiplying for the start and then doing like multiplying that by a certain amount to get a distance out to see what's in front of me.
Yeah, I don't think we have like a Fulstrum check or a Fulstrum trace. Is that what they're called?
Fulstrum?
Fulstrum or Flustrum? I can never remember.
We always get into how to pronounce words debates on this.
Yeah, well, I don't have anything from here, right? Like, this camera has no information on Fulstrum or Fulstrum. So, I
mean, one way to do it would be like you can do like a cone check kind of thing.
Yeah.
Like, I mean, you basically just do like a.
Well, cone check is usually the easiest thing to do.
Yeah, that's kind of how I would do that.
Because your camera's square.
Mm-hmm.
You could do
frustrum.
Frustrum. That's what. Yes.
Everyone's getting frustrated with your frustrum.
Frustrum. That's what I'm looking for. Yeah, we can draw the debug.
Draw a debug frustrum.
But can we get a No.
Frust.
We have no frust on our camera. So.
Huh.
But really, it's just an angle.
Yep.
Do a little math. Do a dot product.
Yep.
Of your one axis and your other axis.
Mm-hmm.
If both are true, you're in the angle. Done.
Done.
Like, that's kind of like what I would do.
Makes sense. All right. That kind of gives us the base of how to do that. Daniel Skipper Games.
Skipper Games.
I don't know if his name is Daniel Skipper or if that's just the name of his company is Daniel Skipper Games. And his name is like Rob or something. It's just a name. Daniel Skipper Games asks also how expensive each trace is, since I've seen people claim on other forum sites that now that we have faster CPUs, let's say, okay, hang on, he's getting into some Unreal Tournament stuff. All right, have faster CPUs, trace expense doesn't matter, and just go nuts with them. As we've kind of proven here, it's not too bad. You can kind of go nuts with them as long as you're not rendering.
Define going nuts.
Yeah, going nuts is relative in the sense of like, you know, we did 36,000 here, but if we were rendering it, that was a big hit, and if we weren't, then it really wasn't so much of a hit because it just depends on what you're doing with it too. Like you can do a ton of traces and it not really hurt anything, but if you do a ton of traces and then tell it, oh, use those traces to then activate, do other things, those other things will just add up really fast.
Yeah, it starts adding up.
Yeah.
We weren't really doing anything outside of the traces themselves.
Just a raw trace by itself isn't going to cost too much, but it's all the things that typically surround around doing a trace-based thing, like if you're shooting an instant hit gun in Unreal Tournament, which is kind of part of the example here, well, that's going to do a series of checks, and then whatever it hits, it's going to fire off impulses. It can create secondary actors as far as like making an explosion here, which is like an actor of itself.
But it's at the end of the day, that's one trace.
Yep, but at the end of the day, that's one trace, and the trace is really light.
And the trace is super light.
It's everything else.
Everything else that you do.
Everything else that people do around traces that make them heavier. So.
And also remember, you can spread them out over time. Don't trace everything at once.
It doesn't have to be on the same tick, man. It's okay.
It's all right.
You know.
And it's also, like I said, we use PhysX. I'd have to check with Ori, but I wonder if we're doing these on the GPU.
What, these?
Yeah.
You know, off the top of my head, I don't know.
I don't
if it's
think so.
On one or the other, but
No, we can't be. No, we can't be because yeah, no. I was just thinking about the UV from trace. That functionality requires a copy of the mesh to be kept on the CPU.
Okay,
So we have to be doing traces on this. Never mind.
Okay.
Moving on.
Excellent job figuring that one out. And you're,
Sherlock Holmes.
You know, that was good. Good logicking. Zio Yuri, hey Zio, asks how to manage materials / physical materials with Raycast. how to manage them. We can get them through taking what we've hit.
Yeah. What would you really mean by managing?
It's sort of a vague question there, but I would assume he means, can you like get to the materials and physical materials through
You can
the
get to
raycast?
physical materials.
Yeah.
So actually, the material thing is basically no. Well, it's not no.
No, you can get the actor and then get the static mesh component and then get the material component from the static
What
mesh.
if you have multiple materials?
Well, then you get element, whichever
Hold on.
appropriate element.
No, you don't.
Oh.
No, you don't. This is the problem. I've been writing the docs for the UV cord from Trace.
Okay. You're the
And
man who would know.
let me tell you, there's so little that you can do with it without C++ code. Okay.
We need to expose some things then.
Let's do a get really quick. Let's do a break. So, what are we getting from our hit result here? We get our Physmat, our actor, our component.
Okay.
Okay, so we get our component. The easiest thing that you could do, if you wanted to know specifically a material, is you would have a physical material that maps to a material. But
Okay.
then you run out of materials or physical materials really quickly. Because I think you only have like 64 of them to start. So really not great. Hitting a component and saying like, okay, well, let's cast a static mesh component, right? All right, you have a static mesh component. Okay, let's get materials. Okay. You get an array of materials. Okay, now how do you map from this to this? You can't. We're not returning that data to you. So, but a material, if you do hit complex, can have a Physmat. So you could return the Physmat.
Okay.
And to be like, oh, this is metal material. And so I know I need to do metally things.
Yeah, plink noise, and then you can,
Whatever.
This is where you do a branch on int kind of.
Right.
Yeah.
But you can't. There's no way to get a one-to-one mapping of your material in Blueprint. I need to clarify this. In Blueprint, there's not a reasonable way to do this. C++, all things are possible because you have access to all the data.
All that source code.
Not just the limited subset of data that we're playing around with here. I mean, even face index. If it was a procedural mesh, I could probably do it, but then I would already know the materials that I'm applying to each face. So, okay. Yeah, very difficult to do in Blueprint. If I remember correctly, it's incredibly trivial to do in C++. It's probably like a few lines easily.
Well,
But it's not something you normally need, right?
Mm-hmm.
So,
All right.
anyway.
It's good to know. Yep. Let's see here. Are you also going to cover skeletal mesh interactions too? Yes. So for any of these collision channels, your skeletal mesh can also have these channels applied to it, just like a static mesh. There's no reason a skeletal mesh couldn't get hit with these traces, and then a skeletal mesh, you even get like the bone information off of that if it's a skeleton. So that's where it says bone name and all that near the bottom. So yeah, you can absolutely use it for that, and there's no.
Now, skeletal meshes are a little different.
Well, what's a little different about them?
Well, they return from the physics asset.
Oh
So
yeah, correct.
if you don't have a physics asset, they don't return you anything.
Yeah, so that is
Even if you do hit complex.
excellent point. This is good because when you actually look at a character and you turn on what is it, view
I don't
collision.
even think I have a person.
Oh right, because that's the skeleton is actually like just some arms,
Well, hold on.
and he might not even have collision because it's just arms, but I'm not sure. But yeah, this is important. Your character, as we often talk about in game design,
He does have.
your character is really just like a series of capsules to collide with, and then a capsule that it runs on. So there you go. So
This is what you get.
Those are actually what it's going to hit, and not the actual body itself. So
I'm going to clarify this again.
yeah,
Even with trace complex on, you are not getting this.
yeah,
We're not going to return this. We're going to return the capsule here. We're not going to return his mesh here.
that's correct.
There's something else I was thinking about skeletal meshes, but I can't quite remember. All right, anyway.
If it comes to you, we can bring it back up. But all right, those are the little caveats about that. This question is from Hancor. So the next question here is from Slayamin. What is the performance cost of a ray trace? No, okay, so we did. Sorry, we already covered that. There's a few of these in here that were just
0.02 milliseconds per 360 line single traces.
Yeah, this is a measurable unit of some sort. I'm sure we're going to call it 1 Ian's of
yeah, right,
of cost. It's one whole Ian of cost. And that's how we are going to...
I am now official
a unit of measurement. Hey, if a Pascal is a unit of measurement, then an Ian can be as well.
Perfect.
So, let's see here. Providence 77. What's the real difference between location and impact point? And the practical reasons why you would use one over the other. Same for normal and impact normal. These impacts versus normal versions of them.
That is a very good question.
Just normally how you preface, I'm not totally sure.
Yeah, I'm not entirely sure. I think this has to do with trace complex and not complex. Like the location... Oh, no. The location of the hit in world space was a swept shape to test. This is a location where you can place the shape in the world.
Okay.
It's not really useful for line traces. Line traces will give you the location and the impact point. They'll be exactly the same. Because they are exactly the same. What if you use a sphere? Well, your hit location will be the center of the sphere, but your impact point will be the exact point where the sphere intersected with your object. That'll be your difference. Same thing with your normal and your impact normal. So your normal will basically be the normal of the trace. Like, this is the direction we're going. Your impact normal, well, if your sphere hits on the edge of a box, you know, well, that impact normal is going to be way different than the actual normal of the trace. Again, a lot of these show their usefulness in shape traces, but not specifically for line traces. But we use a ton of line traces, right? Like, oh, well, these things are exactly the same. Like, well, no, not really. Impact normal is also... brain. Impact normal is also the surface normal of what was hit. So if we go into our world here, cancel, selected viewport. So as I shoot the wall, the bounce back there, that's one normal, but the surface normal of the wall is always straight up. So that's one normal that I have where we're bouncing off. That would be my reflection normal. But the normal of the wall is actually the normal that we're returning for impact normal. Whereas the normal that we're giving you would be the normal that I'm shooting at. So the wall would be pointing straight at. The normal that I'm shooting at would be the one that comes from the gun here.
All right.
Bouncy ball. Anyway.
Cool. Let's see. Atanas asks, is this relatable at all to the environment query system? Yeah, in some ways. It's not. It's not that it's a direct one-for-one. Like you're gonna. So let me back up. The EQS environment query system. It does have options for things like it basically can see, but there's essentially like a line trace option. It just whether or not it can trace to it, but that's the equivalent there of if you don't want to use a whole like EQS like determination system, you could just do, or this would be good for AI for determining whether or not it can see something instead of using a whole system for that. This is much faster and lighter.
EQS is about making decisions.
Yeah, it's about a series.
Things you can see.
Yeah, it's like making a series of. It's making a decision based off of a series of values, and this would just be like getting one of those values.
Yeah. What if I wanted to know all the boxes within a 50-foot radius of me?
Yeah.
Right. Like, okay, well, you do a sphere trace. A 1 unit. Oh, by the way, that's something we did not talk about, but it's a good thing to talk about.
The sphere trace is a 1 unit kind of thing.
Yeah, so for any trace to work, the trace has to move an amount.
Yes.
Doesn't matter how little the amount is, it has to move. So if you do a sphere trace where your start and end are the same, you will return nothing.
Yep.
Even if there's a bunch of stuff in it, because your trace didn't go anywhere. But if you do a sphere trace where the difference in the start and the end is 1 unit, you return everything within the sphere trace. So that's actually something very important to remember.
Okay. Cool. Next question. Difference between object channel and trace channel. Object channel actually wants you to put in what the object's type is.
Object type?
Yeah, so it says...
Which is defined under your collision presets. So in this case, it's a physics body.
So yeah, there on the right, just above all of your collision channel information, you just have one type that you can be, but you can have multiple channel interactions of various kinds.
Yep.
So...
and this will return regardless. So this is object type is a physics body. Even if it ignores everything.
Yep.
It will still return a trace of physics body when it is collided with.
Yep, it can
when it is traced against.
It can be invisible, and everything in the traces can be set to ignore, as you said, and still return something because it hit an object of that channel that you've determined. Versus trace is just arbitrary words. Well, channels can also be arbitrarily made up too.
They're all channel. The channels are set up to be actual like visibility things where it's think about them like sight. You want to be able to, a bush will overlap your sight, but it won't completely block it. A wall blocks your sight.
Yep.
So that's how the channels are attempting to work there. So if you do a multi trace by channel, you will get the first blocking hit and nothing else. If you get multiple overlaps, then a block, then you will return successfully. So like we said, our first box here, overlaps camera and ignores visibility. Whereas our second block, is standard, so it blocks visibility and camera. So we could trace through this guy on visibility and camera, and we'd get an overlap on camera, but then we would still stop at this guy before hitting our last brick here, and he would not return.
Yep.
So if you're doing like bullet penetration stuff and you need to do a rough check before you actually start doing heavy calculations, that's why you would use that kind of tracing. That's really the major differences between them. There is that, outside of that, functionally the same, but trace responses will obey the ignore block overlap, whereas object traces don't care about any of this. They only care about your object type.
Yep. All right. Thank you for the question, Bloody Bobby. Next question is from Element 808. How would you accomplish a click trace between objects? For instance, you have an object above another object. You want to click somewhere on the lower object and set the above object to the XY position of the click. So I guess it's
there's
like...
this is
there should be like an under mouse option, right?
I want to say it's in your controller?
Yeah, it should. I think it's in the controller. Controller type blueprints have the mouse stuff because that's where your input comes into, and so that would make sense that the controller holds mouse data.
It's really easy. It's cursor or
it's like
trace.
I think it's hit under cursor or something like that. But there is in fact a node that is just get mouse position. No, get mouse. So get location underneath the mouth. I'm sure that chat's probably already like over here like, come on, Alex. We know this word off the top of our head. It's like, I can't think of the last time I did a trace under mouse click. It's just been a while, guys.
Mouse. I'm pretty sure it's
cursor.
Hit.
Dun, 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 dun.
This exists. We've seen it. I've used
it. Uncheck
Fine.
context sensitivity.
We won't do context sensitivity.
Yep. Yes, let's do
we'll
it.
Just do cursor.
Get hit result under cursor by channel.
Or by objects.
Okay.
It goes in the player controller.
Player controller, yep.
So we just cast to player controller, which we don't actually have. And then this hooks up just fine.
Yep.
Like so. And so this literally returns a result with the mouse. Which, interestingly enough, all this actually does is it traces from your camera through the projected space into the world of where your mouse is.
Yep.
So the center of the camera through the mouse, it gets like a UV position on the screen and deprojects it into space. So.
Oh, Oninator had in fact in chat been like, come on, get hit result under mouse cursor. We typed
Like,
that.
bro.
We typed it. We just had the wrong context.
This one actually has to be from the player controller. Though.
Yeah. It's specifically built into the player controller class.
We don't actually have a player controller for this.
So if you're trying to do it in some other kind of actor or a pawn or something, and you're having trouble finding this, it does have to come out of player controller class specifically. It is.
I guess we just use the default player controller. I don't even know. Anyway, I'm not gonna deal with the templates here.
Yep. All right.
What else we got?
That's the last of that one. The real Gressica, the real Gressica.
Okay.
You all right?
Yeah.
Asks, is it possible to combine the capsule trace with the use of nav mesh for functioning with BB blackboards? And nav proxy links are not cooperating for some reason. Okay, so instead of using like nav proxies, could you use capsule trace to determine whether or not you can
move through some? Yeah.
Yeah. It seems like. Oh, sorry. It's pronounced Jessica. It's. Gotcha. Sorry about that. The real Jessica.
So yeah, you can use capsule traces to figure out if you can move through somewhere. If nav proxy or whatever is giving you a hell of a time. I know that they're not the most intuitive things to use. Really, the nav proxies are just about giving a hint to the AI that even though a nav mesh doesn't exist here, you're free to move through this location from this point to this point. So really useful for defining falling off ledges or potentially where he can navigate through a ladder. But it's mostly there to let him know that he or she, whatever, your AI, can move through a location.
Yep.
Whether or not he should or not, I mean, it could be on fire. I mean, or it could be a ladder that he doesn't know how to climb.
Yep.
I mean, all these things could be a thing. But yeah, if you're trying to figure out if you can go through a door, definitely, firing off your capsule trace and being like, okay, here's the angle, here are my start and my end. I figured out how to get through there. Move to this location on the nav mesh, and then start applying force to your guy to like flick him through the doorway. Because you're not going to be able to use move 2 to go through.
Yeah, because if it's
no
got
nav mesh.
Yeah, if it's got collision and no nav mesh, then yeah, you're gonna have to.
You need to.
You basically get to a hot spot and then just push them through the door,
or animate it, or do whatever.
Well,
I mean, additive.
Push the door, animate it, make it look clean. But at the end of the day, just kind of make the.
Hey,
capsule,
buddy, you need to go through the door
here now. Yeah.
Just give him a quick push.
Yep. That makes sense. All right. Bloody Bobby asks us another question. Any arced parabola line traces for the projectile distance of an arc trace, something like that? So yeah, like if you were doing a grenade toss, you see games like Gears of War, for instance, when you're about to throw a grenade, it actually makes that arc and predicts it beforehand.
Yeah, we have a projectile path.
And there you go. And that's actually what that one would be.
Yeah, it's basically it's an arc trace.
Yep.
Start position, and then your launch velocity.
Yep.
So you don't really know your start and your end, but this will enable you to figure out masses and things like that for like grenades and whatnot to figure out where they're going.
Yep. Yeah, I kind of feel like if you type in like arc line trace, that should show up too.
Arc line.
I mean, like, I don't think it does right now.
Oh, you think it should?
I think it should. Also, you don't have context sensitive turned on again. But this is a really cool. But now I'm thinking about like, wow, because I've used it before for like, shooting like the balls and the yellow ones and knowing where they're going. But now that I'm looking at it, like, yeah, this would actually be really good because there's out hit. It's all there. Everything's there. So yeah.
Yep.
Cool. So yeah, if you want to use it, that's it. And also, I think we do. If you use the VR template that Tom Lumen had made, there is an arc to the pointers where you point and teleport to, so you can use that as an example. And I think there's maybe a couple other examples, but that template right there should get you started. Cool. Let's see here. So next question. Seru-kun asks, since I missed a huge chunk of the stream, have we covered backface voodoo?
Oh, that is right.
Yes.
You only hit forward faces.
Yes, you only hit forward faces. If you want to hit the back face of an object, you have to turn it around somehow. You have to have
No, you don't actually. You don't get to hit back faces. That's just all there is to it.
Like you would have to come up with a system for hitting back faces by knowing the relative distance from your hit location to the other side of it.
Well, no. We're literally talking about back faces. So if you start a trace inside of an object,
Oh, inside of an
and
object.
you shoot out,
I was thinking
you
of
literally
like
won't hit
the
that
other
object.
side of the object just not being
well, no,
visible
I mean,
and-
so if you wanted to, let's say you wanted to know how thick something was. Well, what you do first is you trace through it, and then you get to the end of your trace, and then you try to trace backwards. And if you are unsuccessful in tracing backwards, you kind of keep expanding that until such point as like, oh, I have 2 hits. Great. Okay, now I know how thick something is. But if you're looking for actually like, oh, I want to make sure that I hit the back face of something and I only have a plane,
Yep.
then you probably shouldn't trace complex, and you should have a box collision. Otherwise, you're not going to hit anything.
Okay.
It's just the way the system works. It's not a thing. It doesn't hit back faces. I think that's an NVIDIA thing, to tell you the truth.
Okay.
It's probably actually more than likely it's an efficiency thing, and that's just how it is. It's like what if you traced through an actor with trace complex? What if you traced through an archway with trace complex and you got all your back faces too?
Yeah, I could see how
You
that
would
would be.
get like let's 1,
2,
2,
3, 4.
3, 4 results
Yeah.
of the same actor, right? Like that seems kind of wasteful. And so I can see a programmer sitting there going like, maybe we shouldn't do back faces. Okay, well, we get 1 and 2. Maybe we should just return the result once. Hey, that sounds like even a better idea. So you end up calling things out like that over time to increase performance.
All right. Cool. I think that answers the majority of things. We got one last question that just popped in from the real Jessica again. We'll answer
What you
that.
got?
We'll answer this one real quick, and then we gotta get going.
Get going.
She asks here, would it be possible to use an arc trace in VR from the HMD, but from a locked camera position?
What?
I mean, yeah, you can use these traces in VR. There wouldn't be any problem with choosing the HMD as a start location and then doing something from there. Not sure I totally understand what you mean by locked camera position. Think God mode? I'm not entirely sure how that would function. You might have to ask that one on the forums, and actually that gives me a good opportunity here to say, hey, if we didn't get a chance to answer your question during the Q&A session here today, you can come over to forums.unrealengine.com, and what's up? You're staring very hard.
I'm just trying to figure out where that question
Okay.
was going.
All right. Yeah, if you have a question, you can go over to the events section of the forums, forums.unrealengine.com. You can search for whichever discussion we were having, and you should be able to comment there, and we'll get back to you as soon as we can with as many answers as we can. But yeah, that's about what we can do for today. We all have to get off and do various holiday stuff, but
I'm
we'll
going back to
see.
slacking off.
Yeah, that's true. I mean,
Vacation.
you know, it's his day off. It's probably a good day to chill. And I'm going to probably keep working because we got UE4 Jam stuff coming up, so I got to keep doing that. Clint over here is being awesome and helping me out with that on Thursday as well.
Has he been flashing up on camera?
Yeah, I think he has. I think he's maybe injected some cameos of himself. See, don't laugh. You're going to hurt yourself
No.
more. I'm so sorry, buddy. But Thursday, we have Tim coming on for the UE4 Jam winners. So the December UE4 Jam winners, we're going to hopefully get to play through as much of your games as possible. Have him for a limited amount of time, of course. He's a busy guy. He's awesome, though, and he's actually going to make it. And so, yeah, we'll do a quick little interview, talk about the year in review, and play your games, reveal the winners, and, get some live gameplay going. So we'll see you all then. 2 o'clock on Thursday, right here, 2 o'clock Eastern Time. Should clarify, right here, same Unreal channel, all that. What? Same Unreal time, same Unreal channel. There.
All right.
So I'll see you guys then. Until then, thanks Ian for coming out, even though you're sick and it's your day off.
Yep. It's all good.
All
you
right.
guys have a great holiday season. We'll see you next
Later.
year sometime.
Yeah, we'll see you next year.